The Big Bang, the beginning of the universe. How did it all begin? This is a question echoing through the centuries. Picture the universe as a vast ocean of darkness. Then, 13.8 billion years ago, a singularity, smaller than a grain of sand, explodes. This event, known as the Big Bang, is not just an explosion in space, but the very creation of space and time. At this moment, everything we know and are was concentrated in an infinitesimally small point, which suddenly expanded. At that instant, the universe was a superhot soup of elementary particles, a boiling cauldron of energy. Unimaginable temperatures and indescribable forces acted on a microscopic scale, shaping the future of the cosmos. There were no stars, galaxies, or planets yet, just pure energy, waiting to transform into matter. Astronomy is our favorite subject, and if it's yours too, I recommend subscribing to the channel. The first moments, the Planck era. In the first moments, we are in the Planck era, the realm where the physics we know today does not yet apply. Here, in the innermost depths of time, the laws of quantum physics and Einstein's general relativity intertwine in ways we still struggle to understand. The universe, at this point, is an enigma wrapped in high energies and extreme temperatures. In this era, lasting only a brief moment, the universe's fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, may have been unified. It's a moment of infinite possibilities, a state beyond our current understanding, where the fabric of space and time is being woven. The force of gravity, shaping the primitive cosmos. After the Planck era, gravity emerges as a distinct force. This fundamental force begins to shape the expanding universe. Think of gravity as a conductor, leading the orchestra of the cosmos. It pulls and manipulates matter, forming the first structures in the still young universe. At this stage, the universe is still a mass of particles in frantic agitation, but gravity begins to impose a subtle order. It plants the seeds of future galaxies, stars, and planetary systems, initiating a cosmic ballet that will last billions of years. Birth of the first particles, quarks and leptons. As the universe cools, we enter the phase of forming the first particles. Quarks, fundamental elements that make up protons and neutrons, begin to combine. Along with them, leptons, such as electrons, start to emerge. These are the first pieces of the complex puzzle that forms matter as we know it. In this primordial cauldron, a phenomenon known as the quark-gluon soup prevails. It's a state of matter so hot and dense that quarks and gluons, particles that hold quarks together, move freely, an extremely energetic and chaotic environment. The four fundamental forces, structuring the universe. As the universe continues to expand and cool, the four fundamental forces assume their distinct roles. Gravity, as we've seen, begins to shape large-scale structures. The strong nuclear force keeps atomic nuclei together, despite the repulsion between positively charged protons. The weak nuclear force plays a crucial role in nuclear reactions, like those powering the sun. And electromagnetism, perhaps the most familiar to us, governs the interactions between charged particles, like electrons and protons. Each of these forces is vital for the formation of the universe as we know it. They work in harmony, creating and shaping atoms, molecules, planets, stars, and galaxies. It's an intricate cosmic dance where each force has its specific role in the choreography of the cosmos. Inflationary expansion. The universe grows. Like a balloon inflating at a dizzying speed, the universe undergoes a dramatic transformation known as inflationary expansion. Imagine a universe so small it could fit in the palm of your hand, and in a fraction of a second, it stretches to reach astronomical dimensions. This inflation is not just growth, It's an exponential acceleration that expands space itself. During this phase, quantum irregularities are stretched to cosmic scales, seeding future galaxies. Inflation solves several mysteries, such as why the universe appears so uniform and why the geometry of space is incredibly flat. It's a crucial transitional moment that defines the large-scale structure of the universe we observe today. The awakening of matter, formation of the first atoms. As the universe expands and cools after inflation, we enter a crucial phase, the formation of the first atoms. This period, known as recombination, sees the birth of the fundamental building blocks of the universe. Electrons, until then free and wild, begin to bind to atomic nuclei. The result is the creation of neutral atoms, mostly hydrogen and a bit of helium. This change transforms the universe from an opaque and nebulous plasma to a transparent space, allowing light to travel unimpeded. This light, emitted during recombination, is what we observe today as the cosmic microwave background radiation, a luminous relic from the universe's early times. The emergence of light, the era of recombination. After the formation of the first atoms, the universe enters an era marked by a monumental event, the emergence of the first light. Before this, though filled with energy, the cosmos was dark, its light trapped by the dense plasma. With recombination, photons are released, flooding the universe with light for the first time. This primordial light, once freed, travels through the expanding universe, stretching its wavelength to become the cosmic microwave background radiation we detect today. It's a silent but eloquent witness to the first moments post-Big Bang, a window to the cradle of the universe. Cosmic structures, formation of the first galaxies. The first structures to form in the universe are the galaxies. Imagine clouds of gas and dust slowly pulled together by gravity, beginning to cluster and condense. These are the seeds of the first galaxies. Under the influence of the mysterious dark matter, these gas clouds begin to collapse and form stars. These early galaxies are different from what we see today. Smaller, less organized, but crucial for the cosmic future. They are the birthplaces of the first generations of stars, forging the heavier elements that will be the building blocks of life. This is a period of intense stellar activity, an era of formation and transformation that sets the stage for everything that is to come. The importance of dark matter, the invisible mystery. Dark matter is one of the greatest enigmas of modern cosmology. Despite making up about 27% of the universe, it does not interact with light, rendering it invisible to our telescopes. But its presence is felt through the gravity it exerts, influencing the formation and rotation of galaxies. Think of dark matter as the invisible backbone of the universe, a skeleton upon which galaxies are built. Without it, galaxies could not form as we see them. Dark matter helps to explain why galaxies spin at the speeds they do and why they cluster in specific ways. It's a silent but powerful force shaping the cosmos. Accelerated expansion, the role of dark energy. In a universe full of surprises, dark energy might be the biggest of them all. Discovered through the observation of the acceleration of the universe's expansion, dark energy is a mysterious force that makes up about 68% of the universe. Unlike gravity, which pulls things closer, dark energy pushes them away, accelerating the expansion of the universe. This discovery revolutionized our understanding of the cosmos. Previously, it was thought that the universe's expansion was slowing down. Now we know it's accelerating. Dark energy is a constant reminder that there's still much to learn about the universe. It's key to understanding the ultimate fate of the cosmos, whether in constant expansion or an eventual decline. The birth of stars, illuminating the cosmos. Imagine a cosmic orchestra playing the symphony of creation. This is the beginning of the era of stars, a crucial chapter in the universe's story. Within immense clouds of gas and dust called nebulae, the first chords are played. Gravity, the silent maestra, pulls the gas and dust, concentrating them in increasingly dense regions. As these regions collapse under their own weight, the temperature and pressure at the center rise until, finally, the core ignites. A star is born. These first stars are giants, much larger and brighter than most of the stars we see today. Their light is powerful enough to start dissipating the nebulae around them, lighting up the cosmos for the first time in millions of years. They are the elemental factories, forging in their cores the heavier elements that will eventually become the building blocks of life. The era of galaxies, forming the great structures. With the first stars, we enter the era of galaxies. Dark matter, which has silently shaped the cosmos, now plays a pivotal role, acting as a gravitational attractor for gas and stars. The first galaxies start as small clusters of stars, but fueled by gravity and mergers with other galaxies, they grow in size and complexity. It's a cosmic dance of epic proportions. Spiral galaxies like our own Milky Way begin to take shape, with graceful spiral arms swirling around bright cores. Elliptical and irregular galaxies join the celestial ballet. Each galaxy is a world unto itself, a stellar ecosystem where new stars are born and old ones die, each contributing to the grand narrative of the universe. Supernovas and heavy elements, cosmic alchemy. Stars, in their majestic existence, are not eternal. The largest and most massive reach a critical point in their lives where the nuclear fuel runs out. What follows is one of the most spectacular spectacles in the cosmos, the supernova. In a cataclysmic explosion, the star disintegrates, releasing tremendous energy and scattering the elements it forged in its core. This is the moment of true cosmic alchemy. Elements like iron, carbon, oxygen, and many others are created in the nuclear furnaces of stars and then spread through space in supernova explosions. These elements are essential for life as we know it. We are, literally, made of stardust. The emergence of life, a cosmic miracle. Finally, we arrive at the miracle of life. On a small planet orbiting an unremarkable star, on the outskirts of a common spiral galaxy, an extraordinary phenomenon occurs. From the elements forged in stars and scattered by supernovas, life emerges. First, they are just simple organic molecules, but over time, these molecules become more complex, forming the first living cells. Life is resilient and ingenious. It adapts, evolves, diversifies. Forests, oceans, and deserts fill with a myriad of creatures, each a wonder of cosmic evolution. And amidst this diversity, a species emerges capable of looking up at the sky and wondering about its origins. We are the children of the stars, seeking to understand our own cosmic history. Choose your next video.